In this video, we are going to discuss and understand about a very important concept called the principle of counting. See, whenever we talk about principle of counting, now this is not, of course, it's a basic concept of counting itself. It's more like how we are going to count the number of objects. All right. Now, when I say how we are going to count, you might be wondering like, what is the meaning of that sentence? How we are going to count it? Now, let me explain what we are going to do. Suppose, let's say, you have a particular word. Okay, we'll take a very simple word. Let's say we take this particular word. See, we have a word banana. Now, I'm going to ask you, in how many ways you can arrange the letters of this particular word? All right. Now, let me repeat again. In how many ways you can arrange the letters of this particular word? Okay. So, I start to count. Right? So when I start to count, this is one way. Banana is one way. Another way, what we can write? So I can write it something like this. So B, N, A, and N. This is another way. Right? So you can change the letter again. You can change the letter. You can keep on doing it. But my question is, for how long will you keep on doing it? And what if you lose count in between? So how do you count? This is exactly the question what we are going to answer now. All right. So to understand this principle of counting, what we do is here there are how many letters are there? So we have 1, 2, 3, 4, 5, 6. There are 6 letters. Right. Now, whenever you have these kind of words where the letters are repeated. Now, one thing I want to tell you here. Look at this. Look at this. These two. And of course, look at this also. These 3 are repeated. Likewise, N is also repeated. First we'll do for A, then we'll go for N. Now, whenever you have these 3, suppose if I interchange this here and suppose if I interchange this here. Does it make any difference to the word? No. Or suppose if you take this here and if you take this here, does it make any difference? No. So, whenever we have repetition, for that particular letter, the repeated letter, if you interchange, it makes no difference to the word. Correct? So, if I have to calculate totally how many combinations are there? Totally. So, we start with the first one. See, for the first empty place, you have 6 different possibilities. That is 1, 2, 3, 4, 5, 6. Right? 6. Once you choose one of the letters, now you have 5, then 4, 3, 2 and 1. Isn't it the same as 6 factorial? So, totally we have 6 factorial. But, suppose you have letters A, and A. Okay. If you interchange these two, it makes no difference. If you interchange these two, again, makes no difference. So, there are 3 letters when you interchange. For the final word, it has no impact. So, I divide it by 3 factorial. Now, you might be thinking, why division? Because repeated subtraction is division, right? So, I keep subtracting all the cases where these 3 A's are together or these 3 A's are interchanged. So, repeated subtraction becomes division. So, we divide by 3 factorial. Likewise, which other letter is repeated here? N is repeated 2 times, twice. So, again 2 factorial. So, we can say, therefore, the total number of ways of arrangement, okay, arrangement will be 6 factorial by 3 factorial into 2 factorial. Now, I'm not going to solve this because I know you know that how to solve this one. Now, the solving part is not really important. The important part is how do you get it? The method, the procedure is more important than the final answer. Clear? So, whenever we have words like these, where you have multiple letters are repeated, because here A is repeated, N is repeated, correct? So, whenever you have multiple letters repeated, that many number of times you divide by the factorial. Clear? Let's do one more example based on this one. To solve this one, first, how many letters are there? There are 7, right? So 1, 2, 3, 4, 5, 6, 7. So there are 7. First, what do we do? For the first gap or the first block, whatever we have 7 different possibilities, correct? Then 6, then 5, 4, 3, 2, 1. So in total, we have 7 factorial, correct? After that, we look into the repetition. First repetition. No, P is not repeated. S is repeated because we can see that S is repeated. How many times? Twice. Correct? So, the number of repetitions. That is going to be 2 factorial. Right? So, finally we can say therefore total number of arrangements. Total number of arrangements will be 7 factorial divided by 2 factorial. Fair enough? This is going to be the final answer. We'll do one more example. After that, we'll look into the problems part. Alright? See the next word. The word is addition. T-I-O-N. Now, guys, please pause the video. You solve it on your own. And then at the end, check the answer whether you have got it correct or not. Alright? So, please go ahead. Pause, solve it, then check the answer. I hope you have all got the answer. Now, let me solve this one. First, we'll calculate how many letters are there. So, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 spaces or 8 letters we can say. So, total, it's going to be 8 factorial. Alright. Then the repetitions. D is repeated twice. Correct. So, for the repetition, first we have 2 factorial. Then after that, I is repeated twice. So that's again into 2 factorial. Isn't it? So what can we say then? We can say therefore the total number of arrangements. Total number of arrangements will be 8 factorial by 2 factorial into 2 factorial, which I want you guys to solve it completely and get the answer. Fair enough? So remember, to summarize this particular part or summarize this particular part of the video, the principle of counting, if you have n letters in a word, totally it's going to be n factorial. And if you have a particular letter repeated some number of times, you divide it by that many factorial. Alright, that's going to give us the total answer. Now in the next video, we'll look into few problems and examples of the same.